What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to learn how to factorize a specific type of quadratic, which is called the difference of two squares. So this is a special type of quadratic that you could see, and the most important thing is being able to identify them quickly. The maths behind it is actually a little bit easier than some of the stuff that we've been doing, but the identification, if you can do it really quickly, will save you a lot of time and a lot of work, especially in test conditions. So if I've got something like this, I've got x plus 3 all multiplied by x minus 3. I could FOIL this out and I would get x squared plus 3x minus 9. Now when I collect my like terms after this, I can see that the plus 3x and the minus 3x always are going to get rid of each other. So my final answer, once I've simplified, is just x squared minus 9. Then to just see it in one more example, I've got x minus 5, x plus 5. If I FOIL this out, I'll have x squared minus 5x plus 5x, and then minus 25. The minus 5x and plus 5x cancel each other out, so my final answer is just x squared minus 25. And this is actually the rule for the differences of two squares. You might have seen in both of those examples, it was the same values. We had x and 3, and then x and 5. The only difference with the signs in the middle, we had minus and plus. This means that they will get rid of each other in that simplifying step or the collecting like terms. And we can use this to our advantage. So the algebraic rule is that if we have something that's a minus b and then a plus b in brackets next to each other, we can straight away, instead of doing that FOIL step, go straight to the answer a squared minus b squared. This doesn't help us out that much when we're doing expanding. FOIL's pretty good. It might just save a couple of seconds, but where it really shines is with factorization. If we can see one of these difference of two squares, we can put it back into the brackets really quickly without having to think too much. So here we've got something like x squared minus 16, and you might be told to factorize this or put it back into brackets. It's hard to do this. You're like, oh, there's not really a common factor between these two, but we need to recognize that, hey, there are a couple of squareds. The x squared's easy to see. Oh yeah, that's x squared. But the 16 is actually just 4 squared. And what's important to notice here is there is a minus sign in between. We sometimes use difference to mean minus. For example, if I asked you, hey, what's the difference between 10 and 4? You would say 6. The way we work that out is 10 minus 4 is equal to 6. So the same thing here applies. We've got two squareds, x squared and 4 squared, and the difference in between them. So once I've worked out what those two squares are, I can put it into our rule. We know that a plus b, a minus b, is going to give us this nice difference of two squares that we can see. So for this one, it's pretty easy. Hey, the first square is x and the second square is 4. So x plus 4, x minus 4, that's all we've got to do. Again, we can FOIL this out, but we know that those like terms in the middle would be minus 4x and plus 4x. We can just get rid of those. So we're left with x squared minus 16, which is perfect. Once you can see this trick, it's really easy to solve questions like this. X squared minus 81, it's definitely difference, and we've got two squareds. So the answer is just x plus 9, x minus 9, full marks. If you want to write x minus 9, x plus 9, that does not matter. It can go either way. But the important step is just saying, oh, there's a negative sign between two things. I can just square root both of them and get full marks. In order to do these really quickly, please make sure that you're on top of your squared numbers. So you're 1, 4, 9, 16, 25, 36, on and on and on. If you're not 100% sure, please go through and look at these ones. It'll just save you a lot of time if you're trying to do these questions quickly. The best thing about this is that it even works if it's not a perfectly square number. So if I have x squared minus 5, you're just like, well, we can't do it. 5's not a square number. It's not going to square root perfectly. But what I was doing with those last ones, 16 went into 4, 81 went to 9. We can do the same thing with the 5. Root 5 all squared is equal to 5. So all I need to do is recognize that, hey, I still have this x squared term, and instead of thinking of the 5 just as a whole number, I can think that as root 5. Root 5 multiplied by itself, or root 5 multiplied by root 5, is equal to 5. So all I've got to do for this answer is be like, hey, I can have x plus root 5 in one bracket and x minus root 5 in the other. If you haven't done surds yet, I've got a whole video series looking at why this works completely. But for this, all we need to know is if it's not a square, plus or minus root that number. Just to FOIL this out to make sure that we've got it right, we've got x minus root 5x plus root 5x. No way, they're going to get rid of each other. And then root 5 multiplied by negative root 5 is just minus 5. So my answer is x squared minus 5. That's what I started with, so I know I got it right. This even works if you've got a non-monic quadratic as well. So instead of having just x squared by itself, this one is 4x squared. The square root of 4x squared is just 2x, and then the square root of 25 is just going to be 5. So once I've worked those two things out, all I've got to put down is 2x minus 5, brackets, 2x plus 5, full marks. Again, recognizing these ones is the key. If you can see two terms with a negative sign in between them and you're asked to factorize or put them back into brackets, really quickly identifying that, hey, these are actually both square numbers, even if they're not, can really help you out. Knowing this rule that a plus b, a minus b, immediately turns into a squared minus b squared, and vice versa, so it goes the other way, will be really helpful in test conditions, because if you're not sure what to do and you're looking at a term and going, there's no common factor, you might be looking at a difference of two squares. Thanks so much for watching this lesson, and I'll see you later.